Hello everyone and welcome back to Minic Analytics. In this video, we will be talking about the support vector machine and we will be using the same in-cells method classification. So before I get started, so if you are new and you like this type of content, please consider subscribing to our channel. We are welcoming you to a wonderful community. Hit that notification bell so you never miss any of our updates. Also, don't forget to give this video a thumbs up and feel free to leave any of your questions and comments behind. Once again, thank you for joining me today and let's get started. Support vector machine is a supervised learning algorithm that is often used in classification as well as regression tasks. The primary goal or the primary objective of using the SVM is to find the optimal hyperplane that best separates different classes of data points while maximizing the margin between the data points. In terms of applications of support vector machine, it's used in a variety of tasks such as image classification, spam detection, as well as anomaly detection. There are some key advantages of using the support vector machine, and one of them is that it is very adaptable and efficient because the support vector machine can manage high dimension data. It can also be applicable in nonlinear relationships. When using the support vector machine is that allows for the specification of the kernel functions. The most common kernel functions in support vector machine include the linear, polynomial, and the radial basis. So when conducting an analysis using the support vector machine, you are free or you have the leeway to use any of these kernel functions. There are some basic things that we need to understand or to know when using the support vector machine. And one of them is the hyperplane. So a hyperplane is a decision boundary that separates data points into their different classes. So when you look at the image on your right-hand side, you can see that the dark line between the two dotted line, that's our hyperplane. In a two-class classification problem, you can see that the hyperplane is like something like a wall or a flat line that creates as much space as possible between the data points of the different classes. In a 2D space, this hyperplane is usually regarded as a line. So it's just a line that separates the data points. But when you move to higher dimensions, this line now becomes a hyperplane. So the support vectors, these are the data points that are very close to the hyperplane. The support vectors are very important because they determine the position as well as the orientation of our hyperplane. Imagine this is the region between the hyperplane and the nearest data points for each classes. This margin, it represents the separation of the safety buffer zone that exists between the classes. And when using the SVM, we are trying to find the hyperplane that maximizes this margin. So we don't want to lean too close to either of the data points. A larger margin is desirable because it indicates better generalization of the unseen data. So that's why we want to maximize that distance. So basically, I think by now you have a clear understanding on the theoretical part of what support vector machines are. Now, I want to move forward to where we will be applying the support vector machine using a practical example. For my analysis, I'm going to be using the Jupyter notebook. So let's head there. So we will start by importing the Python libraries. So I imported the pandas as well as the NumPy Python libraries. So you can just import this by typing import pandas as PD and import NumPy as NP. Then I moved forward to load the data onto the Jupyter notebook. So I used the read CSV function from pandas. Then my data stored in a variable df. When I use the head method, now the output from the head method is just will be our data frame, and it will display the first 5 rows in our data frame. So that's how you can import the Python libraries as well as load the data. I want to inspect the shape of our data frame. So I will use the info method. So when we run this, as you can see in our data types, you can see that the first column, retailer, the data type of the values is labeled as objects. For the retailer ID, the values are labeled as integers. But our main focus, or our major point of concern, is between the columns between price per unit to operating margin. As you can see, we expect that the values in these columns should be either integers or floats. But when we look at the data types for the values in those columns, you can see that they are being represented as objects. So we can see that there is a clear misrepresentation of the data types in those columns. So under data cleaning, I'm going to rectify this. So I will do this by dropping the special characters that are found on the values in those columns. So for example, for the price per unit column, we can see that the values are having a dollar sign. So I will be replacing those special characters and passing in the correct data types for the values in those columns. So let's head to data cleaning. So under data cleaning, as I said, the first step will be removing the special characters. So our step number 2. So let's begin with the first column, the price per unit column. For this column, I'm going to be removing the dollar sign as the special character. And when removing these special characters, I'm going to be using the replace function. So I'm going to be using the replace function in Pandas. So replace. So what are we replacing? Since we are dealing with special characters, we are going to use the backslash. Then we pass in the special character that we are going to be replacing. Then we say we also add what we are going to be replacing that with. So I'm going to be replacing the dollars special character with an empty string. And since you are following a regular expression, I'm going to use the regex. Once we are done with that, so under this, as I have said, we're going to replace the dollar sign with an empty string. And since the combination is following a specific order, we are going to use the regex. Once we are done with that, we are going to now be changing the data types in those values. So for this case, I'm going to, instead of it showing object, I'm going to replace that to, let's say, float. For this, let us use a float. So to change that, I'm going to use the asType function. Then you specify, you pass in an argument and say float. So just to see if we are successful with that, let me use the info method again, just to see if we were successful in what we were doing. And when I run that, you can see that for the price per unit column, we have now changed the data type to a float. We will be doing for the other columns. So for the column number 2, which is the unit sold, again, we're just going to be repeating the same thing. When we run that again, you can see that for the unit sold, the values we have now changed to integers. So you can repeat the same for the total sales, operating profit, as well as the operating margin. So let's do that. Okay, so this is for the operating profit. Again, this one will change the values for the operating margin. And let's run that to see. For these other columns, except the price per unit, we converted the values to integers. So as you can see, the price per unit is the only column we converted the values to floats. But for the others, we converted the values to integers. So now I think we have a correct representation of the data values in those columns. And if we recall our data frame, we can see that from the price per unit column to the operating margin, we have successfully removed the special characters and changed the data types of the values in those columns. Right? From this, now we can then move forward to the next activity that we are going to be doing. We can then move on to the major objective of what we are going to be doing. So Remember, we are going to be using the support vector machine in sales method classification. So for this analysis, remember is that we are going to be using the support vector machine in sales method classification. In our analysis, we are using a data frame from Adidas sales, and this data contains the column the sales method, and it specifies the type of sales method that were used in terms of supplying the said products to their customers or the retailers. So we are going to be using the support vector machine as a predictive tool. Basing on the features that we have, we are going to predict if a retailer will either select, for example, in-store or either online or any other type of sales method that are available. So the first thing that we are going to be doing is that I'm going to determine the different types of sales method. I'm going to target the sales method column and use the unique function to kind of give us the unique values in the column, and these unique values will represent the different types of sales method that were used. So when we execute this, we are getting an array, and this array contains the unique values in the sales method column, and we can see that we are having 3 types of sales methods. Those include the in-store, outlet, and online. Now that we have determined the different types of sales methods, we are going to go on and import the support vector machine libraries and models that we will be using in this analysis. So we are going to import the classification modules. We are going to import, then we are going to also import the train test split module. So generally, these are the modules that we will be using for this analysis. So we have the train test split. So when splitting our data to the testing set as well as the training set, so we will be using this module. When evaluating our model, because it's very important to evaluate your model after training and after testing and training to determine the accuracy of your model. So we are going to be using the classification report as well as the accuracy score. And since our data, as you can see, contains categorical values, we will be assigning numeric values to these categorical values. And to do that, we are going to use the label encoder. So that's why we imported that. And for the standard scalar, some of our values are huge, and while other values are very small. So to avoid the impact of the large values having a dominant effect over the smaller values, we need to standardize our values. And by doing that, we will be using the standard scalar. Okay, so those basically that's how we are going to be using those modules. I will then move on to the next thing, where we are going to specify our features. Of course, we are not going to be using every features that we have in our data frame. I'm going to drop some of those features. So I'll be dropping the retailer ID, and also the invoice date. I think those won't be necessary in this example. So I will be creating a copy of our original data frame based on the features that I will be working with them. So let's first specify the features that we will be working with. So you can either drop the 2 columns, or you can create a variable and just and create a list of the columns that you will be working on. So I chose the latter. So when we run this, you can see that we have dropped those 2 columns. What we are remaining with is the retailer, region, city, product, price per unit, total sales, operating profit, operating margin, as well as the sales method. So the next thing that I'm going to do is I want to, since we are having these categorical values, I want to go on and assign numeric values to these categorical values, so that when we are working with the support vector machine algorithm, it won't recognize these categorical values. There are different types of encoding that you can use. One of them is the one-hot encoding. The one that we will be using for this analysis will be the label encoder. The label encoder, it will be assigning a unique integer or a numeric label to each category in a categorical variable. The first thing I will create, I will specify the columns. I need to create another copy of that data frame with the selected columns. So I don't want to interfere with the columns that are already in numeric or in integers or floats. So I'll create a new variable, specify the data frame that you're going to create a copy, and use the copy function. So we are making a copy of the original data frame cells, and we are doing this to ensure that you don't modify the data in our original data frame cells, because we want to encode specific columns, but not every column in that data frame. Now we are going to start encoding. And when encoding, I will first initialize the label encoder. Then I will be using a for loop. So we will be iterating between the columns in our variable categorical, in our data frame categorical columns. We'll be using the for loop and assigning labels to the values in these columns. And once we are done with that, we can now print our output. From our output, you can see that the columns, retailer, region, city, product, as well as the sales method, we have all assigned them new numerical values. And we didn't interfere with the columns between price per unit to the operating margin, just because we created a new copy from our original data frame. So this is how you can perform an encoding process. And step one will be, you're going to define the features as well as the target variable. So we are going to use the famous X and Y. X will be the features or the dependent variables. So, and we will be targeting the values in the data frame cells encoded. We are going now to specify which values will be our dependent variables, and I will use a list. So those values will be everything from retailer up to the operating margin, and our independent variable, which is the target variable, will be the sales method. Step number 2 will be data splitting. Under the data splitting, we are going to split the data into the training and the testing sets. So the training set will be used to train the model, while the testing set will be reserved to assess how well the model how our model will be performing on a new unseen data. 80% of the data will be using in training, so you want to use a lot of data in training, and 20% will be used for testing. So we will be using the train test module, so it will be helping us to split our data. So we have our X as features, as our dependent variable, and we have our Y as our target variable. So the test size, testing, as we have said, we will be using 20%, so 0.2. The random or the seed value will set it at 42. So to check if your data has been loaded correctly in the respective variables, you can determine the shape for each, and you can see that we are getting the dimension of how the split has occurred. Now, step number 3 will be feature scaling. Earlier on, I had explained to you why we are using the standard scaler. It's because we have varied numbers in terms of magnitude. As you can see, some of the values are very large. When we are training our model, normally these huge values usually dominate over the smaller values, and we get a skewed type of model. So to avoid that, we will be scaling our data. And when I say scaling, we are transforming the features to have a mean of 0 and a standard deviation of 1. And we are going to achieve this by subtracting the mean of the features from each data point and then dividing them by the standard deviation. What is the reason for feature scaling? So without scaling, features with larger magnitude may dominate the learning process, as I had said earlier, and this can lead to a model being biased towards those features. So we are going to be scaling to ensure that all features are treated equally in terms of their contribution in the model's prediction. The first thing that we will be doing, I will start by initializing the standard scalar, then recall our model. So after we have initialized our standard scalar, we are going to fit the scalar on the training data. Okay, so this is just a new variable that we are creating that will store our transformed data, our x-train data. We are also going to transform the testing data using the same scalar. Okay, so by this, we have fit the scalar on the training data and transformed it. But for the testing data, we have only transformed the testing data. We call this and run. You can see we have tried to scale our features in the training set. So we have fitted and transformed those features. For our X test, again, you can just set this and run. We can see that we have also applied the same. For step number 4, will be building our support vector machine model. So we are using a classifier. So I'm going to create the SVM classifier, and we are going to set some hyperparameters. So our kernel, for this case, I will start with a linear kernel. Gamma, we will set it to scale, and for the C, in this case, since we are using the linear, let me just do away with this. They won't be important as of now, but you will see how we are going to be applying that. So if you want to get the hyperparameters for the model that you are building, so to get all hyperparameters, just to see what hyperparameters that you are using for your model, so you can use this line of code. And when we execute, you can see that these are the other hyperparameters that we are using. So we have already built our model. Then we are going to the next thing will be fitting the classifier, the model that you have been building, to the training data. So that will form our step number 5, and by that we'll be training our classifier. So SVM classifier dot fit. So we are fitting on the X on the training, so it will be X train held as well as the Y train. Okay, so when you see this, that means that we have fitted the SVC classifier model to our training data. So step number 6. So step number 6, we are going to be making prediction on the testing data. So ypred.predict. So when we execute this, as you can see, it's making the prediction. We're making prediction using the testing data. Okay, so as you can see, we are getting zeros and ones. For step number 7, we are going to be evaluating the model performance. And the first thing that we are going to do is we are going to determine the accuracy score. So we are determining the accuracy score of our model. So accuracy from the output, as you can see. So in our classification task, the accuracy means the proportion of correct predictions made by the support vector machine model on the testing data. We determine the accuracy in terms of the correct predictions made by the model on the testing data, and we are getting an accuracy of 0.63 or 63%. Okay, so we can also check for model performance when we look at the classification report. The classification report, just print classification report for the Y test and Y prediction. And from that, we can see that the classification report provides a detailed summary of the performance of the support vector machine on multi-class classification. The classification report, we are including the metrics precision, the recall, and as well as the F1 score. So for precision, we can see that for precision, we are trying to answer the question of all the instances predicted of class X. So for class X, either 0, 1, and 2, how many were actually of class X? So for this, we can say that 52% were actually for class 0, 75% for class 1, and about 49% for class 2. We are having quite low precision for classification in class 0 as well as the class 2. Let's use a confusion matrix to see how we were classifying our data points. So let us import the module and let's create the confusion matrix. Then we move forward and print our output. So from the confusion matrix, you can see that these diagonal elements from 200, 745, and 273. So the diagonal elements of the confusion matrix from top left to bottom right, these values represent the instances where the model made correct predictions. So for example, in the top left corner, we made 200. So in the top left corner, 200 instances of class 0 were correctly predicted as class 0. And for class 1, 745 instances were correctly predicted as to fall for class 1. And for class 2, 273 predictions were made correctly. So when we look at the other elements in the confusion matrix, so when off the diagonal, these values represent instances where the model made incorrect predictions. So basically, that's all for today. So for this video, our main goal was using support vector machine in sales method classification. Alright guys, that's all for today. Thank you for your time and thank you for watching. And before I sign off, if you have enjoyed this and like this type of content, don't forget to give this video a thumbs up. You can also subscribe for more content. Hit that notification bell so that you stay updated. We look forward to having you next time. So until next time, see you.